BP_FP character is child of the MAS character. It's done in the most primitive and simple way. Just for the example, there is an anim BP connected to it. Again, it's done old school in the most simple way. There is some stuff that I run through the blueprints, especially all the play montage stuff, because I really like it. In terms of input, so I'm using also enhance input, but I was still lazy and I left it here just on a traditional input, just with the left mouse and right mouse. There is a very basic change character state. This is just to simulate the testing regarding the functions on the AMSGun when on equipped and on unequipped is triggered. By no means you should have any major expectations from having a complete code or not. So if you press PC2, equip, and 1 again. So this is just to simulate what you would be testing if everything works. Again, there are some debugs prepared to assist you with your development. Most of these inputs are already in the enhance input. What is not standard is the crowd system. I'm not sure what's the idea with generic crowd system in Unreal or how much it advanced since I last checked. But basically I found it quite unusable because there is no inbuilt system that will check if the character can uncrouch and not getting stuck. As you see in my system, to crouch, yeah, that's easy. I mean, we just crouch, but when we release crouch button, we first start uncrouch timer. So that will start a looping timer that will then trigger more stuff. There is also stuff running on the tick, and then it triggers another sphere. Even when the line trace is showing there is nothing above the head, before finally uncrouched is triggered, there is a sphere overlap that triggers slightly above the capsule of the character. So when he starts uncrouching and this sphere overlap triggers something, he will go back to crouch to avoid getting stuck in the objects. As you can see here, we have additional debugs in the settings, so we can debug line trace and debug obstacle trace. See, it's quite simply how it was done. We have these box traces running. There is tons of code with it to make it perform in the behavior like it does. There is a different behavior from the top. There is also, you know, crouching. If he hits the gun in the ground, that stops. The main thing is there is no jittering, and that took a lot of work, but I'm not gonna go in the video explaining it. Just have a look in the C++ code, have a look on those values, and you can try to lower those float values by 10 or 20 and you will see how the jittering starts and you will understand why it's done the way it's done. So you see, when we are on this edge of the uncrouch, we are running this line trace, and that's still handling the overlap. Once this check is green, he will get the command to start uncrouching, but there is an additional sphere trace that will check like really is the capsule not gonna get stuck, and that's when it's allowed to uncrouch. Also worth mentioning, during uncrouch I kind of tweak the collision and I shift the mesh position. Same thing I'm doing during knockouts when I had issues with camera going through the walls. So there is quite a bit of code that is handling the repositioning of the mesh. I'm not gonna go in the details in the documentation. That's why you are paying money to get all the C++ code you need. Just use F12, go through the functions and reverse engineer it. If we look through the settings, there is quite a bit of settings. You can hover over them and play with it. Also important, there is a whole separate section for the settings of montage. They are all as soft object pointers because there is a lot of data in it, and I'm just loading them synchronously in C++ and pass it to the blueprint function. So if we look on the reference, there isn't much. The materials, I already commented how it can be done to get rid of those, and here we only have 2 montages. So in terms of our blueprint version, there isn't much. What I left exposed to blueprint is here. You can set up what you will be testing in your package build. This blueprint AMSOverlap is a very simple blueprint. You click on the settings. There are 3 settings. Set the pickup type, which is only battery or cartridge. You can't use a mineral here. And desired level, and that will update the battery to that level. If you run on true, then all batteries within the inventory will be updated to that level. Now blueprint BP_PC, that's the child of the C++ class AMSPC, which is parented to the player controller, mostly handling the communication between the character and the gun and the widgets. All widgets are controlled from here. These are all soft class references. There is kind of a code that you will have to mainly tweak in your project with this update inventory data unload that will basically populate the menus based on the data from the AMSSaveGame and updates the visuals regarding if you had a battery attached to the gun. Best again to trace it from C++. So as you can see on the begin play in the AMSPC, just run a bunch of stuff to set up the variables and create the widgets. Then it continues to the code in the BP part. On the tick we are only updating the game time that we need to store. So there isn't much more to this class. It's all kept to the minimum to kind of demonstrate the functionality. Most likely you will transfer this code to your main player controller class in your project. AMSSaveGame is a subclass of USaveGame. We just declare some friends classes so we don't have to make the getters and the setters, and we are storing all the essential stuff that we want to know as a permanent storage. The corresponding data for each particular pickup class is stored in own tmap, and then we have all the inventory data is stored in a separate tmap, and regarding the spawn data we have in this sample just 2 for indoor and outdoor. The testing map is kind of using the default that will set it, all the data, into this indoor map, and it's kind of done in the very minimalistic way. You shouldn't really bake it to the shipping build once you are done with the testing, and whatever maps you will add, you need to also add your own T-maps. This is here to use as a pointer to the active data map, and we kind of set the value with the reference for whatever is the active map. So that way we can use the code with this pointer, and then by reference we are directly changing data within the corresponding T-map.